All right, so today we're going to do some more, I would say maybe supplementary, but some additional kind of stuff that can help you write better quality code. So we're going to look at debugging, and we're also going to briefly look at type hints in Python. So we'll start with debugging. Zoom in here. So VS Code has a lot built into it, including a debugger for Python, and you can. It also basically works well with Django, which we haven't seen yet, but we will later. So if I want to, let's say this is my file, right, and I want to debug it, I can just go in here, run the debugger, and I get two options immediately. One is run and debug. Two, I can create a launch.json file. So we'll look at that in a sec, but first we'll just run and debug. Then we have all these options. Since we're just basically using a normal Python file, you're almost always going to choose this unless you're working on Django later. So Python. And Flask, by the way, is another. So there's some other Python-based frameworks. Python file, and then it actually executes the code and nothing happened, right? So it executes the code, it printed out this stuff, which is from here, but doesn't really do you much good. So let's go raise an exception here, and we'll run this again. And notice that it stops, right? So when it encounters an exception, it stops. And that's because of what's happening here in this bottom left. So by default, it will basically create a breakpoint for you if you have an uncaught exception, which we do here. So if you just run the debugger on its own, it'll execute the entire file, and it will just keep going if there are no exceptions. If there's an exception, it will stop execution and let you know. And we can then step through and so on. We get an exception. But that's probably not, you're probably not going to want to do that either. Just, wait for an exception to occur. You're probably going to look for something else. So what you do in that case is you set a breakpoint. So over here in the gutter to the left of the numbers, the file numbers, you can hover over there and you should see a light red circle. You can click there and it will go bright red, I guess. And then the next time you run it, it will stop there. So it's going to run all of the code and then it's going to stop at this breakpoint. And once you're stopped here, then you can continue executing by pressing here. So let's also take a look. So one benefit of debugging is that you can kind of get a snapshot of your code as it's executing in the middle of execution. So over here in this variables panel, we have local variables. We have I equals 0, and that's coming from here. We also have our list, my list, which is coming from right here. And then my num, which is coming from here. Globals, right. And then res, which is the result of this function. You can also go into the debug console. So this little, what do you call it? I don't know. You go here into the debug console, and you can also access variables. So I can do like it's like being in the console. My num, and then right? So you can kind of play around with stuff if you want to see what's going on. Run quick check. Oh, what if I did this? Maybe I could use this method and so on. All right. And then over here, so we have step over. So step over will basically, if you're calling a function, it won't make you go into the function and execute line by line. It'll just execute it and then give you the result. Step into will basically go line by line by line. And then you can restart or step out, or you can just basically continue, should go all the way. Yeah. So if you step into, we're going to call get sum. So now we're going to actually call it on line 27. If I do step over, it should just return instead of actually going through line by line in that function. All right, so that's a regular breakpoint. You can also use a conditional breakpoint. So if you create a breakpoint just by clicking there, and then if you right click on the breakpoint, you go to edit, and then you just write any Python expression. So something that evaluates, basically it's going to evaluate the true or false. So if I, instead of clicking through this for loop, maybe what I'm concerned about is maybe like when I is 8, something seems to go wrong. So rather than having to click through that every time, you can do, so I want to stop it. I want to catch, basically, pause the execution of my code when I is 8. So now when I run it, notice that I is 8. So it ran the code, ran through the for loop a bunch of times, and then when I was 8, it stopped. So you get some, this can just be kind of a time saver if there are particular things you're looking for.
Is that dependent on the line that it's on? Like if you had the breakpoint on line 19, for example, and you said when I equals 8, will it still break when I is 8 in the for loop, or will it not? Will it totally miss that?
I don't think that it will break. Let's do that. So I should be, if we were to print I after this for loop, it should be 9. So I is 9 at the end of this, like after the for loop.
Okay, let me rephrase my question. If the breakpoint is on, say, line 19, and you set it to I equals 9, so will it break when it after the for loop is done, or will it break in the for loop while when I first starts equaling 9?
I'm not 100% sure. Let's find out. Well, let me make a guess before I try. So I would say that it probably won't see this until it executes. So my guess is, why don't we try a different value rather than 9? All right. Okay, it did stop. So, yeah.
Okay, so the position does not matter when you set it to be conditional.
Apparently, yeah. It might matter in the sense of you might have multiple variables with the same name in different scopes. Yeah, it's good to know.
Could it be that it did that because there's nothing in between the breakpoint and the end of the function? The last expression that was written.
It could. So we can try moving it somewhere else, but it looked like it stopped. So if you looked up at the variables, it was. So let me do. And we'll do the breakpoint right there. So hide does get printed, which is a little weird.
Yeah, I think it is defaulted to the line above it when the breakpoint is on an empty line.
It just kept executing.
It's probably because Python interprets on the fly your indentation. And so the moment you put that print line, it's unindented from the for loop. And then therefore, you're out of the scope of that function.
Yeah, that's what I was trying to say.
Yeah.
Chris said it way better than I could.
Let me try that again real quick. Yeah, I need to save this here. So
It's good you're testing edge cases here.
yeah, why does it? Maybe just because I doesn't exist, so it's evaluating a false. That's probably what's happening. Yeah.
So if you
Yep.
move that, yeah, so if you move that above that debug line, just one above that print statement, it still thinks that you're in, it hasn't decided to take you out of the for loop block until line 19 happens because it's unindented. So Python reads the white space. So right when you're on line 18, it still thinks that you could potentially be trying to do something inside that block until you write something that's unindented. And then it figures out, hey, the for loop block has ended. So if you put a debugger, because the debugger isn't attached necessarily to, it's being interpreted with Python as well. So it's like,
Is it debug or
breakpoint?
breakpoint? Thank you.
Yeah, you can use it's basically a PDB shell.
That's, yeah. So that won't actually.
It'll put you in
Having
a
it be
PDB
conditional,
shell, but
yeah.
it's a little bit different than
Yeah.
the other breakpoint.
Okay. Well, that's good to know. I mean, I could play around with that. That was unexpected behavior initially, but it looks like that doesn't actually work. So I guess you do have to pay attention.
Yeah, if you're working with blocks of code like conditional statements for loops or function blocks, you just have to make sure that your block has ended. Like Python has basically ended that block by the next line, right? Like it hasn't, line 18, 19, and 20. If there's nothing between there, it really hasn't decided if it's finished that for loop yet because of white space. And so now when you put that print statement, when Python hits the print statement, it's like, oh, the for loop block is done. That's where it ends at. So from where the colon is at down to where the next line unindented started, that's how it determines where the block of code is at for the for loop.
All
It
right,
makes
cool.
sense, but it is weird.
Yeah, good to know. I never really tried doing that before. Okay, so we've got, let's see, breakpoints, conditional breakpoints. Let's talk about the launch.json file. So if you, so the starting menu is the same, click on Python file, and it will give you this default configuration. So if you're debugging frequently, especially if you have special special needs or special things that you want to do, you can basically indicate those here. So it's just preserved, so you don't have to manually do a bunch of setup every time. So there are a number of different options. For the most part, we're not going to be worried about anything too complicated. But one thing to know is that here by default, VS Code will basically run the file that you're currently looking at. So if you're running a larger application, then probably want to start there. So this will be whatever file you're currently looking at. So you can do things like, for example, you saw that when we just ran it by itself without any breakpoints, it executed the entire thing and didn't stop unless we raised an exception and didn't handle it. So you can actually change that. So you can do something called stop on entry. I'll make this true. It's false by default. You can make this true. And then when we go, so now we have this VS Code folder, which probably you would want to add to your git ignore. But we have a launch.json. So now when we run the debugger, it's going to use that configuration. We go here, click run. Oops, let me do this. Run it from here with the currently open file, right? The file I'm looking at right now. So notice that it automatically stops execution on the first line. Rather than just executing everything and only stopping if there's an exception, it stops automatically on the first line. So now we're in this other imported file. Now we're back here. Right. Okay. So that's one thing you can do. Another thing you can do is you can do something called just my code. So if you're, especially if you're using third-party stuff and some built-in codes, you can actually end up stepping through everything. So everything that your code uses. So by default, just my code is set to true. You can set it to false. And let's go ahead and actually I'm going to leave the other one too. Let's do stop on entry. All right, so now I'm going to go back here and I'm going to run the debugger. Keep going. And notice the call stack here. So there's ordinarily when you run this without this only run my, when this is true or just the default, you don't see all of this stuff in the call stack, right? You just see the module. We're not in a function call right now, so we should only have this module, but under the hood, Python is doing a bunch of other stuff. So you can actually look at these call stacks this is from Python code. So here's the initial thing Python calls when you start running. I don't go through this, but it's here. It's actually on the stack. So probably don't want to be doing this. But if there's some, off the wall chance that the third-party code you're using has a problem, you want to check that, you can do that. Okay, so probably not going to need to mess around with the launch.json too much, but you can. So that's, I mean, that's the basics. Oh, okay. So let me also say, let's talk about all these variables. I'm going to delete this. So I'm going to set a breakpoint here. Okay, so another thing, another feature. So notice that this is a recursive function. So I have a bunch of stuff on the stack, but not any of that, you know, nitty gritty under the hood Python stuff. I can add if there's a value that I'm especially concerned with, I can add it here. So for example, let's do total. So maybe this was a bad time to do this, but so I can, and now this is going to be tracked for me. So I could, of course, look up here and check it, but if I only really care about one value, you can just put it there and save yourself some trouble. So those call stacks popping off. Right. So yeah, that's basically it. So the debugger can be handy instead of always just using print statements all the time, which are, you know, print statements are fine, but you can start moving away from that a little bit, get a little bit more sophisticated. So another another tool that's available is something called Ipdb. So there are a number of command line debuggers that are available. The Python standard library has one called PDB. I assume that's Python debugger. But there are other ones that people use that are so there's another main kind of, I guess the main standard one that people use now is a third-party one called Ipdb, which is kind of a combination of, there's one library called IPython and this built-in PDB, standard library PDB debugger. So someone kind of combines them. So you get it's just a fuller featured version of PDB basically. So we can use that. We'll have to install it. So in order to install a third-party module, you're almost always going to want to create a virtual environment first. Does anyone happen to know the steps for doing that? So we do, we will run the module is called venv, V-N-V, and we'll need to run it as a module. So Python -m venv, and we're going to create a virtual environment, which is going to be a folder basically, and we'll give it a name. So let's call it my venv. You can see up here that this folder has been created. And once we create it, we need to activate it. So we're using it in our current environment. So you do source, my venv, whoops. Okay, so now I can see that I'm actually using my virtual environment. So once I have that, I'm going to download Ipdb. So here's a cheat sheet that has all of the stuff in it, but all the commands. We'll do pip install Ipdb. It'll take a second. All right, and so once we have this going, once we have this installed, we can use it. So I'm going to, at the beginning, you know, you can put this anywhere. So we're basically going to add like essentially a breakpoint for IPDB. So I'll have to import IPDB. And then people often do this on one line in part because you shouldn't leave this in source code in a production code. So IPDB dot set, what is that? Set trace. So this is basically going to create a breakpoint or a point of entry for IPDB. So now if I run this code, I'll run my file, and it's going to stop execution, right? And now I have this little, I'm basically in a REPL, kind of like a debug console here in VS Code, where I can actually do stuff with the code. So I can print, oh, I haven't done anything yet, but my func, so. So let me do my func. We'll just call this function. Right, so this function just reverses the string you give it. So I can use, but so the issue is that the rest of my code, IPDB doesn't know about the rest of my code yet. So if I try to print my num, right, it doesn't know about it because it hasn't executed that line yet. So even this line that it's currently on, sorry, it doesn't, it hasn't executed it yet, so res doesn't have a value. Okay, so there are a number of different ways you can move around. So there's W. Don't worry about memorizing these or anything, but there's W, which is where. So this gives me the traceback. So I'm on line 5, right, of this file, myfile.py, and here's the line that I'm on with with 2 surrounding lines. I can change that. So I can press L basically to give me more context. So now instead of just 1 line on either side, I have like 5 or 6 lines on either side. You can also configure this. We'll go back to this W, and then just like VS Code, you can kind of step around. So you can go step or next. So now I am in this other file that I've imported, right? Because I'm importing this function. And now I'm on line 2. And this returned. So I get a return value here, which is the reverse string. And then I continue on back into line 7 right here. So now if I print, right, so that variable has a value now. So I can keep going. And then we have a list here. Okay, so we can keep stepping over, and we're going to keep printing things out. There's also a nice thing you can use, which is until, basically a way to get out of for loops. There we go. So you'll have to use it at the end because I think what it does, it basically checks if it'll pick up if the line that you call it on is greater than, I don't know if this makes sense, but we're on 19, so if we call until on 19, it will pick back up once you're past line 19. Okay, so now we're in this function call. So I'm gonna keep going here. So we're calling the function, we're gonna call it again. Now for stack traces, you can actually go up and down. So that's what you can find stack trace, you can go up. And we'll do so I'll just keep going. And when I share my screen, this code just so slow. Okay, so now I'm at the oldest frame. So I'm back at like the root frame that I started with when I executed. And if I go down, so D, now if I do total, say D, so notice that the number is going up, D. So I haven't, so in this frame, which is the most recent one, I haven't evaluated total yet. So keep going. And eventually, okay, so eventually we're going to get a return statement. So this indicates that we've returned and we have a value. This is just another way of, kind of getting into your code and taking a look at what's going on as you're executing it. So rather than just using print statements all the time, basically try doing something else. So, all right. So that is basically all I want to talk about for that. I also just feel like introducing typing. So Python has something called type hints, and full disclosure, I've never actually used them, but I see them, and I feel like I see them more frequently. So I'll just introduce you to the basic idea. So type hints are totally optional, but they're introduced, I don't know what version of Python, but and after 3.7, it seems to be basically fully supported. So Python, of course, is not a statically typed language, and that's both good and bad. So there are some people really like the precision of specifying the type that something will be, whether it's a variable or a return value from a function. So you can indicate that in Python. I'm gonna get rid of this, and I'll get rid of this too. So I'm going to just show you what that looks like. So here we have our variable name, and then a colon, a space, and then an int. So if we try to run this now, it should run without any problem. So Python will basically ignore this. but there's a package, something called MyPy. I think there are a couple others, but I think MyPy is the main one, where you can actually run your code with MyPy, and it's almost like doing like compiling your code if you're in a lower level language. So in order to use it, we're gonna have to install it. So we've already got a virtual environment, which is nice. So we'll do pip install MyPy. All right. And then you can actually just run the file with MyPy. So MyPy. And by default, if you don't specify any types, it's not going to complain. But let's see what happens if I do. Okay, so I create this variable, set it to 90, and I tell Python that it's going to be an integer, and then I reassign this. So I get an error. So error, incompatible types and assignment, expression as type string, variable as type int. So if if it's important that you have the same type, you can do stuff like this just to give you a little bit more security. Let's get rid of that. And then same thing with dict. You could do dict. What if I try doing something like this? So again, I get an error on line 12 saying incompatible types and assignment, expression as, right? So again, if I run this, even though it's throwing me an error here, if I run this with just Python, it runs fine because the Python interpreter doesn't care about type ints. But if you want to do static checking, again, this is kind of just like a code quality thing. So you can change this to a list. There's also a whole bunch of other. So if you look at the typing, so that in the standard library, there's a typing. So it's not just the basic stuff like int and tuple and so on. There's more complex types. So Python, of course, is duck type. So there are going to be a lot of functions that don't just take one thing, right? Like you could give it a list or a tuple, right? Basically any iterable or something like that. So you can import these types, and then you can say, rather than having to specify, like be overly specific, you can say, it takes any iterable. So for example, here. So this would also, so this works, and we could do import iterable, and we'll make this as a list is also an iterable. All right, so this is a more general. So that works too. So if you have a function and you want to specify it. So here, when we have a function, you can do, so this is going to be an int, and num2 is also going to be an int, or something like that. And then the return value is also going to be an int. So now we just have basically told whoever is looking at our code that we expect this function to get 2 ints and to return an int. So this is fine. But what if, let's say the second one could be an int or a float, then we could do something called a union. And a union basically just means either or. So union. And let's see what happens if we run this. We get an error. So incompatible return value got float, expected int. So notice that you can ignore this right now. So so we said in our signature that the second parameter can be either an int or a float, but we didn't change our return value. So what happens if we add an int and a float? Well, we get a float. So even without running, even though this is just static analysis, it knows that there's something wrong here. So that's a good indication that we should change this. So also, I'm going to go ahead and change that. And let's do argument 1 to get some as incompatible type. Oh, right. So does anyone see what the problem is here? Why am I getting this?
If you have two integers, then you'll get an integer. Since number 1 could be an integer and number 2 could be an integer, if you got two integers, you would not return a float.
You need to change the type of num1 to be a union.
Yeah. So what happens? What happens here? So total, when it's called recursively, is going to be whatever these is, which is it's probably going to be a float, or at least it could be. So let's try. So now it's happy with this. But so that's, I mean, that's the basic idea behind type hints. It's likely that you'll see that at some point if you haven't already. I find it kind of distracting, to be honest, a lot of times, but I'm trying to get into it. So, but that's it. So yeah, this is just another thing you could maybe think about using in terms of code quality, or if you don't want to use it, that's fine, but just you'll probably see it. So that's all I got. Are there any questions?